Oh, um, every single time we do that little waiting period, I always realize like I need some waiting music, some jams. Open to suggestions. Feel free to add your thoughts in chat. What sort of jams you'd like to hear while you're waiting for us to get started. Um,
We need our own branded Wherobots elevator music.
yeah, exactly. It would have to be good elevator music, obviously. That's important.
For sure.
Um, Well, thanks everybody for hopping on. We really appreciate you taking the time to listen and kind of learn from what we're talking about today. We're going to talk about a use case that we like. It's sort of bread and butter, what I would say to um, what we kind of consider spatial intelligence. And specifically, what we're talking about is this large scale GPS mobility data and being able to join that to, large scale building polygons. Oftentimes you want to add in places on that as well, so that you really can understand, what types of visits and places folks are going to, especially if you're working in a targeted sort of advertising or any number of other use cases. And actually, we want to hear what some of your use cases are as well as we go through this. Um, but yeah, it's a very common use case that we run into and want to talk through with you all, and then highlight some of the performance gains that we see with some of our users and customers working with our bots today. So, just no further ado, agenda. We're going to do some quick intros. We're going to talk about Sedona, Apache Sedona, and whereabouts. Sedona is used in this scenario all the time. Um, and then we'll get into the use case itself, go to some demo, and then give some closing thoughts and time for Q&A at the end. Um, Sean, you want to introduce yourself?
Yeah, hey everybody. I'm Sean Knight. I'm on the solutions side of things here at Wherobots. I guess I've been with the company for about 7 months now. Before joining Wherobots, I was had a startup in the geospatial space, career in geospatial, and among other things, I was working with this particular use case where we were building these very large GPS or telematics data sets to regions or polygons, whether those be building polygons or zones for some sort of analysis. So very familiar with this use case and excited to talk about it with you today.
Awesome. Very cool. Yeah, I love that you've implemented this. I don't know, probably dozens of times, I would guess, at this point in your career. So yeah,
Yeah, easily.
yeah, cool. So I'm Ben. I lead our go-to-market team. Work with Sean and others here at Whereabouts. Been with the company for just over a year and a half. So yeah, thanks for joining again. So we're gonna jump into a demo, or a sorry, not a demo, a poll. So we want to know, how do you use this mobility data today in your use cases? So feel free to just pop in your answers here. I've launched the poll, so you can answer here directly, and we can hear about what some of those examples are. Cool, flowing through pretty quick now. A few folks with map making, definitely insurance and driving risk. We see that one a lot too. Public safety, human movement, and foot traffic. Yeah, it sounds like that one's actually very popular.
And if there's something else that we did not put in the list there, feel free to add it to the chat.
Right. This is one of the fun things about doing these is seeing what folks have to say. It's funny, I talked about the targeted advertising, but now that's like the lowest at the moment. So maybe I'm wrong, or maybe that's used less frequently than I realized. Map making and human movement a lot higher. Few of you not doing anything with mobility data yet. That's fine. We get it. It's big data. All right, we got about 85% that have responded. I think that's maybe good enough for government work. So we're in that poll and share those results so you can see how things stack up. So human movement, foot traffic analysis is really the number one, 52%, followed by map making at 35%. And then pretty much like a tie, except for targeted advertising, looks like there's the lowest. Uh, and Steve says, I had a location-based media startup several years ago, and I'm interested in how media can be attached to places. Yeah. You got any experience on that one, Sean? I feel like you do know.
And I think we'll chat about that a bit as we go through the demo, but
Yeah.
I think Steve will see it right away how I guess it also depends on what media specifically he means, but if we're talking like ad media, yeah, that's a very common use case for this sort of analysis. So we can dig into that a little bit.
Cool. All right. May go close that one out and we'll go to the next one. So just a little bit about us at Whereabouts. If you're newer to us and our team, there's a few things like one, our founders are the creators of Apache Sedona. They're researchers uh, in academia originally that started this project that was originally called GeoSpark. Now it's got, 20,000 some odd organizations that are using it. We collectively have hired a large number of folks, engineers, solution architects, um, folks across the domain that are just really love this type of data and are really kind of obsessed with it. And that's really what we bring is that spatial data obsession. And really what we're focused on as a company, as a team, is building geospatial and spatial data into the modern data stack so that you don't have to um, go through these sort of contortions, I guess I would call them, to deal with this very oftentimes challenging data type or data types, because there are more than one. And ultimately, we want to do that in order to help you advance your missions and your goals as an organization or as a team and building data products about our physical world. That's really what we're all about. So when we talk about this sort of idea of elevated spatial intelligence, really, what we want to enable is teams to create this very complete view of what happened, what could happen over time or any geography, and ultimately have some clear intelligence and insight about what the physical world is happening in the physical world or what's likely to happen in the physical world. And in order to do that, you need to be able to fuse a number of different data types together. You have to take, in many cases, you want to bring insights out of aerial or satellite imagery, imagery from drones, imagery from airplanes, imagery from all things circling the Earth. Take this mobility data type as well, extract insights out of that, converge that, join that with physical representations of or digital representations of the physical world, and then add your business context because that's ultimately like where the value, the deep value is that physical, your business context, your organizational context that you have. The problems and the challenges that we run into very frequently is oftentimes related to this. Data processing related challenge. So there's oftentimes incomplete coverage of the types of functions or types of analyses that you are able to complete. That can oftentimes result in, creating custom, functions that you have to maintain or manage on your own, or can result in delayed intel or slower processing time, which reduces your ability to innovate and then drives up your systems and maintenance costs. So these are very data team specific challenges. So if you're familiar with that, that's the types of things that we look to solve. When you're using Whereabouts, when you're working with our system, we want to give you the ability to reach like planetary global coverage, be able to combine, over 20 different types of data or even up to 100, even faster across different analyses and fuse them many times faster with that increased compute efficiency and really unleash what's possible within your data products that you're producing.
And Ben, I'll add a little bit of flavor to that,
Yeah, go
just to
ahead.
ground it in our current context around, joining mobility data sets. So when I had my startup and we were doing this before we became a Wherobots customer, because maybe I didn't tell the whole tale, but we were actually a Wherobots customer for about a year in the early days. And eventually I just kind of saw what the Wherobots team was doing, loved what they were doing, and decided to join up with them. But when we were in our early days, before we were using Wherobots to do these large spatial joins of many, many points, mobility data, sometimes there's ground truth data or other context we were adding, sometimes even aerial, we would usually have to change everything to some sort of simplified index like H3 in order to be able to process it. And even then, we would have problems where our jobs would time out while we were trying to run them. The cool thing about switching to Wherobots is we were able to do those spatial joins with actual true spatial joins between like points in polygons or polygons in other polygons. And I'll show you more about this once we get into the demo phase of things.
Cool. Yeah, I love that story, Sean. Thanks for sharing it. Um, All right, so just real quick on Sedona. Sedona is really kind of one of the core foundations of our company. Like I mentioned earlier, it's used by over 20,000 organizations across many different use cases and situations. A lot of these organizations are using Sedona for these mobility use cases I mentioned, and for obvious examples here, you look at like JB Hunt or Uber or Amazon, um, you know, uh, T-Mobile, like across these different, even Allstate, across these different organizations, this is exactly what the type of analysis is they're interested in, is understanding how this movement, related data relates to their assets and their operations. So again, we've had over 50 million, I think it's like 52 million downloads now. It's growing, continues to grow really, really quickly. Um, Over 200% annual growth, lots of contributors. I think the biggest thing that I'll mention here for those is, if you're not familiar with Sedona, is like you've got over 300 different vector and raster operations. So like 200 vector data functions, 300 or 100 raster data functions, which really unlock the ability for you to do these types of operations very quickly in your data, giving you, lots of capability to, fuse things together, run statistics on them, et cetera. So for Whereabouts, what we're doing beyond Sedona is it's obviously 100% compatible with our open source as well as Apache Spark, which it sort of lives within that Spark ecosystem. It gives you elevated speed, scale, and performance, like over 20x faster in many cases. It gives you the ability to work with these different data types all together, so you don't have to like move data from one system to another to handle them. That's oftentimes a pattern that we are able to reduce or eliminate for our customers. And then lastly, of course, it's all in the cloud. It's all serverless. You only pay for what you use as you're using it. It's fully cloud native. All right. So uh, the very simple way to think about what we're doing and what we have is it's a lakehouse engine for the physical world. So you're able to connect directly to your data. Usually it's connecting to buckets in Amazon S3 or other data systems. You'd be able to take imagery or GPS data or streets and buildings, all these different data types, together with your business context data, so your tabular data that's related to your organization, and then build these data products, discover what's going on with them, really explore them, understand them further, identify a core data product that would be useful for your users, automate those, and then produce these products very efficiently and very quickly. Um, the automation part is really critical, especially once hey, I need to update this data set on a daily or hourly even basis. Can helps unlock that. And again, solves these different use cases across many different industries that have lots of operations that are related to or dealing with, our planet. All right, so quick question for folks: how you all are processing spatial data today? Let me just bring my polls and quizzes back up. All right, so poll two, let's go, let's launch. So yeah, what are you using today to process your spatial data?
And if there is something else, feel free to put it in the chat, or if you're using multiple of these, you can also add that to the chat. I don't think we have the capability to select multiple for the polls, but something to think about for the future. Oh, I see ClickHouse from Michael. Yeah, you don't hear a lot about ClickHouse for spatial, but I do know they have some capabilities there.
Yep. I think they've added like a dozen or so functions. Yeah, DuckDB. We should put DuckDB on that with the spatial extension. Obviously, that's a good one.
They should definitely be on the list. Yeah.
So good question. What are you using for the ground truth data? Yeah, so I mean, when I talk about ground truth data, I'm often talking about like data from, for example, like Overture Maps Foundation, or a data set that like OpenStreetMap that represents real observations that have been verified about the Earth, right? Or close to being verified, not necessarily always perfect. So often those things, those data sets are available in the Wherobots spatial data catalog for use.
And Janet, I can add a little bit more use case specific ground truth. The unsatisfying answer is it always depends on exactly what we're building and what the use case is and what ground truth would be appropriate. But if we're talking about foot traffic ground truth or ad tech or things like that, I'll give a couple of examples in the demo just verbally of ways that people have done that. We won't actually have it incorporated into the demo, but I can certainly talk about it a bit.
All right, so we didn't get quite as much participation this time. That's fine. Uh, we'll go ahead and if you have a question or you have something you want to share now, you feel free to add it in the comments or we can unmute you at the end here. So yeah, we got some, I guess, let me see, GeoPandas, very frequent, very common. Looks like Apache Sedona on Spark, EMR, Postgres. Um, those are ones we run up against really frequently, which is fair. I think the challenge that we see oftentimes with those is you're kind of locked into a single machine architecture or vertically scaled architecture that only scales so far. It's great for certain types of scenarios, but once you get to the larger scale stuff, it can break down. All right, cool. Um, Let me keep going here on the slides, and then I'll pass over to Sean. So,
Yep. And
yeah,
just for the Postgres, PostGIS users, I would also say I also see timescale DB and PostGIS. That's cool. Yeah, I also don't hear a lot about timescale, so it's good to see them in the mix. So the Postgres and PostGIS use cases, we also still see quite a bit of that people using those to serve data to the front end, not necessarily as the processing engine on the back end, but some sort of processing engine like Wherobots that writes to like an S3 bucket, and then while it does that as a source of truth, can also write to a Postgres database, and then Postgres can still serve the front end for a lot of like mapping applications. So that's one we're seeing a lot. I don't know if anyone in the chat is doing that sort of thing, but it comes up quite frequently. Back to you, Ben.
yeah, no, that's great. I appreciate it. Um, Just quick on performance here. When we say, it's performs well at scale, these are just a few of the benchmarks. We already have it out in the Sedona library or Sedona GitHub repos, but you can check out the Apache Sedona Spatial Bench, which is a benchmark that we've published. We're about to publish the results of our own testing. It's very similar if you're familiar with TPCH as a database benchmark. So it covers over 12 different functions and joins. This one here is sort of a preview of something that we've done quite a while ago that we'll be updating once that benchmark is out. But it's very large spatial joins that are these point and polygon things like OSM nodes and postal codes, or Overture buildings and postal codes, or Overture buildings and OSM nodes. So very large, joins that we're doing, and it gives you a sense for versus other distributed computing architectures what you get from a results perspective in terms of speed and performance. Um, and then one last thing that's just kind of cool. We're actually like announcing this tomorrow officially, but we'll give you a little preview since you all decided to join us today. Um, if you're using Databricks or if you're familiar with Databricks, we are now giving our users the ability to federate their data and data governance with Unity Catalog. So now, if you're a Databricks user, you can directly connect to Wherobots and directly connect to your data in your Unity Catalog, expand your coverage and your functions that you have. Databricks has like native within their serverless capability, like 80 functions for spatial data. So you can expand that to the 300 plus functions that you get with Wherobots, and really enable that sort of complete understanding of the physical world and innovate with that local to planetary scale, vector, raster, tabular data sets all in one engine. And it's 100% compatible with our open source Apache Sedona and Apache Spark. So you can push those things back and forth with your data and Databricks and really get more value out of it. Cool. Just a couple closing things before I pass it off to Sean. So, some of the advanced functions that you get in our platform are things like map matching. So taking, road network like grids and taking GPS points and being able to snap those points to a road network when it's driving or biking or even other types of movement. Um, Geocoding, so being able to run those types of geocoding or reverse geocoding, uh, building and creating travel isochrones. Um, there's also the ability to create distributed PM tiles, so serving those PM tiles into those customer user-facing applications, and then also other advanced functions like geostatistics, and there's a geostats toolbox that gives you a lot of additional functions there.
And Ben, just curious, like out
Yeah.
of these more advanced functions, what would you say is your favorite? What do you think is the coolest?
Great question. I mean, I don't know. I feel like the one that has like lots of really interesting use cases is the geostats toolbox. Just because like one of the things that we see, for example, you mentioned H3 earlier, Sean, right? Like a lot of people like to aggregate data up to H3 and look at things from a hotspot perspective visually. But when you zoom in or zoom out from those aggregations, it oftentimes you don't get the real truth of what is or isn't a hotspot because the level of zoom that you're in will impact what is actually or not a hotspot. Whereas with that type of cluster analysis, you're able to actually statistically significantly or show the statistic significance of your hotspots. So anyway, that's one that I think gives lots of cool insight.
As far as the broadest utility, yeah, I would probably agree. It definitely does the most, applies to the most use cases.
Yeah.
For pure Flash, I like the isochrones or the map matching, but yeah, I think I'd agree with you on the geostatistics.
Are there metrics available on response time and accuracy of these algorithms? So we are absolutely able to help kind of like benchmark those types of things, Janet, and various different ways we could work with you to do that. Um, yeah, you further to say there, Sean?
No, just that yeah, exactly like you said, we have to dig into the weeds a little bit more, as far as like, things like response time, speed, accuracy. It all depends on how you tune it, kind of what size infrastructure we're using for it. Like there are a lot of factors that go into it. So, I mean, the unsatisfying answer would be competitive on all of those. We'd be happy to chat with you more and give you more details.
Yeah. Generally, like we see equivalents with like at or above the same sort of functional capability of PostGIS. You just have the ability to scale it up a lot better.
I would also add to that a lot of these. So, like if you think about the geocoding or the isochrones with whereabouts, you can do them in batch. Most of the options on there for doing some of these kinds of operations, like geocoding or isochrones, usually involves an API going to another server. And so, just in terms of response time, you're usually bogged down by network response time. But with whereabouts, you can actually batch process these for very large data sets and then have them at the ready for whatever use case you're trying to achieve.
Yeah, exactly. We can also work with you to like tune them too. So that's something that we certainly have and do with our customers. Last thing I'll mention, this is an area where we're spending a lot of investment in because of the amount of imagery that's being captured about the Earth. There's like new satellites getting shot up into space constantly. It's like every I don't know, couple weeks, I feel like I see a new constellation getting managed. Um, so what we're doing is we're actually enabling you to run machine learning models that are pre-trained or ones that you've trained yourself using spatial SQL or Python, and being able to pull out, extract imagery, extract what a thing is, uh, you know understand, build, create polygons around it. Um, and then use that to actually represent and deliver and serve back into mapping applications. Or other types of scenarios. Maybe it's a risk score, or maybe a risk analytics that you're doing for an insurance type use case, or something else. Maybe it's dealing with like disaster response. We see lots of really interesting use cases out there. So a lot of investment here and existing capabilities and new ones that we're going to be talking about soon. All right, I think this is our last poll. So let me go ahead and launch it. So what challenges do you have with working with spatial data today? Um, Love to hear your thoughts. see if we can beat our previous response level. That one's, yeah. It's funny. We always seem to get like at least one. It's like, yeah, I got this. This is easy. I can do this.
And I always feel envy.
Yeah, right.
Yeah, just spatial use case. It'd be nice to have a spatial use case that's simple, but they rarely are.
Yeah. All right, we'll give it just a couple seconds longer. Ah, you don't need to scale yet. Well, that makes it easy for you. There you go. That's maybe why. All right, we got 55%, so a little bit less, fewer responses this time. That's okay. Um, let's share the results. These are pretty in line with what we hear. So it's really hard to productionize or your portfolio doesn't scale. Um, and can't work with vector and raster data together in one system. Yep. I see that one often. It's what we're happy to help sort of make easy for you. So that's awesome. Uh, if you want to share what your something else is, please feel free. We'd love to hear it and chat about it. Cool. All right. I'm gonna pass this over to Sean. Sean, you want me to just keep clicking for you, or you want to take over?
Yeah, you just go ahead and click through. So the idea here is, once we get into the actual demo, it's going to be very code heavy. We will still have some visuals, but I think a lot about how people learn, and the way I've always learned best is to have a primer or like an overview of kind of what is going to be covered before we actually get into the details so that I have something to attach the details to. So I'm just going to give you guys kind of the quick story of what we're going to do, and where it fits together, and then we'll jump into an actual code notebook and I'll show you how that looks in Wherobots. So yeah, if you want to move forward, Ben, here, we can start here. So here's kind of a rough overview of like what this kind of pipeline might look productionalized. We are only going to do parts of this. We're just going to do sort of a simplified version to show the speed and capability of these kinds of large spatial joins. Um, and but this is sort of what the workflow might look like if you were trying to generate say a visits data set. So you have much large amounts of mobility data as GPS points. All of it is time stamped. You have it, all across the country, and you need to join it to building polygons. So you want to know, okay, who visited this building or how many people visited this building at this time of day or over this span of time. Um, and so you might add in a temporal aspect there. You might have some sort of ground truth data that's going into the pipeline. And then at the end, the output is this data product, this visits data product. So go ahead and go forward here, Ben. And then I'm just going to talk you through the images. So you're going to see this in the notebook itself, but what we're going to have is a very, very large data set of these GPS points, so many that it's actually hard to visualize them. So we visualize them for a smaller region here, and we're actually combining two data sets. So we're combining mobility data sets across regions and near POIs, and then also a very, very dense data set of roadway traffic. So you can see these sort of solid lines here on the roadways. Those are actually just so many data points from visits that it looks solid. Go ahead and go to the next one here, Ben. So what we're going to do is we're going to take that, we're going to combine it, we're going to take this building footprint data set. So this is from the Overture Maps Foundation, and you can see these building outlines here. And then what we're going to do is join those to these building points, or these building polygons. So we're going to just say quite simply, if this point lies, I mean, this is the logic, this is not the actual code structure, but we're going to say if this point is within this building shape, then attribute it to this building. And so go ahead and go to the next one here. And just for our region, we're just going to process for the United States, or as I'll show you in the notebook, we're going to do a very simplified, smaller version, and then we're going to do the big version so that you can see how the amount of time and processing differs depending on the workload. And go ahead and go to the next one here, Ben. So this is just, I think this is 0.001% of the output since you can't visualize the full output because it's far too big of a data set. But you can kind of see some of the regions here where we're seeing big clusters, and then you can go to the next one here. And then The final output is that we're going to make it so that if you were to select any building, you can hover over it. You can see once we've aggregated to them, you can see, okay, we had, in this case, it looks like 836 visits to that building. That may be during one day, that may be during an hour that you're processing it. It really depends on what you're trying to achieve for your business outcome. But depending on how you adjust this workflow, you would sort of figure out kind of how you would want to bin those. And then I think that's the last one, so I think I can jump into the demo here. So let me pull up my demo. And actually, let me start here. Okay. So folks, you should see my Wherobots interface here, not the notebook yet. Maybe Ben, give me a thumbs up if that looks right to you. Okay, it looks good.
I see your.
So when I log into Wherobots,
Go ahead. Sorry, Sean.
sorry. Okay. So when I log into Whereabouts, this is the first thing I see. So this is my sort of Whereabouts interface. I just want to give you a primer on what it looks like to use the Whereabouts platform. It's a managed platform for working with essentially a improved and managed version of Apache Sedona. So we've got our notebooks here. This is where we can spin up a compute cluster. I'll get back to that more in a minute. We've got our data hub. Okay, was not expecting that. Looks like I'll jump over to the notebook and give me just a minute here. Fix that. Okay. Back where we were. So we've got the notebook, we've got the I'm not sure why it's doing that to me. Okay. Well, I guess we will just jump into the notebook is what I will do here because I still have this loaded even if something's going on with my internet today. I did run this while Ben was talking, just because I don't want you guys to be stuck waiting on every query, even though they only take a couple of minutes. But what I'm doing is I'm adding this time flag so that we can time each of the processes, and I can actually show you how long it took to run. Now, this is the primer I was going to give you is saying that essentially what happens is when you spin up a notebook in Wherobots, it spins up a cluster. There are a few different options. You can do kind of a small, medium, or large cluster depending on the size of your workload. This is currently running on a Whereabouts large cluster. And when I do any sort of spatial operation, what it does is it distributes that spatial operation among different compute nodes. And so that's that underlying Spark infrastructure that makes it faster, but it's built on the Apache Sedona. It's built on Apache Sedona, which is built on Spark. And so Apache Sedona creates that geospatial version of all of the processing power that we're used to using with things like Spark. So what we're going to do here is we're actually going to use a simulated mobility data set. And that's that one that I showed you in that first graphic there. And you can see the same thing here. This is just a simulated data set that we created specifically for this purpose. It has many, many roadway data sets. It's actually a combination of two different simulated data sets. And then it has essentially what are supposed to be foot traffic around POIs. So you could imagine this as being the data that comes from mobile devices, or potentially, vehicles in some use cases. But for this one, we're saying we want to look at store visits or building visits. And so we want to assume these are mobile device visits. So we're just going to read this in. What I'm going to do is I'm going to first create a boundary around Bellevue City to do a small version of this so that I can show you these in maps. And then we're going to do the very, very big version that it's impossible to show in maps because it's just too much data. Not because Whereabouts has a problem with it. It's fantastic for doing that processing. It's because my web browser will not render data that large using JavaScript is usually what happens. So scroll down here. So what we're doing is we're taking all of these many, many data points. And then what we're going to do is read in those building polygons that I showed you earlier. So these ones here. And if I hover over them, you can just kind of look. There's more data attached to it, but I didn't include it in the map here just for the way I created the query. This is all using Sedona Kepler, which is built into the Whereabouts platform. So this notebook is in the Whereabouts platform. And what we can do is we can actually do a spatial SQL query, and we're just going to do a spatial join here. So what we're going to do, I'll walk you through this, is if you're familiar with spatial SQL, we're saying select. We want to select all of the geometries, all of the building geometries, and all of the mobility point geometries, and also including the timestamp. And we want to join them in the case where that GPS point, um, where it is contained within the building polygon. And so this ST contains, we've got B dot geometry. So that's one right here. So the first one would be the thing that contains the other thing. So the building contains the point, then it joins them. And then we get this output here. Um, and what we can do is, and then, oh, and I'll just give you a quick idea of how quick that was. So these are relatively small data. This is just for the Bellevue region. So this is just a few, let's see, what is this? This is 600,000 data points is what we're looking at here, which in Wherobots terms is small data. We do that, we get out a table as the output, and then we can actually do a quick aggregation here. And we can say, okay, now this polygon, this building polygon had 200 visits, this polygon had 180, et cetera, et cetera. And we can also plot this as a chloropleth map. And so we can actually visualize it here and say, okay, well, it looks like this one got 107 visits, this one got 188, et cetera, et cetera. Now let's take you to the large scale version, now that you have a primer of what we are trying to accomplish here. So I'm going to read in the full simulated mobility data set. So I'm just going to do a count here, and you can see this is, let's see, that is 10 billion data points across the US is what we're looking at there. It would be nice if I could get it to add little commas in there to make it easier to read, but there we go. You can count your places. And then what we're going to do is I'm going to create a small function here that just does a limited plot. So it takes a very small portion of it. It looks like it takes just 10,000 points so that we can still add some charts, but it's not going to look quite correct. And then for our spatial filter, instead of doing Bellevue City region, we're going to do the entire United States. So I'll go ahead and scroll down here, and we've got these data points read in, the simulated mobility data points. And we are reading in that building data set again from Overture Maps. And in Wherobots, we actually have Overture Maps data all natively integrated. So we have a hosted mirrored version of our own that is very easy to use within the platform. So getting things like building polygons for the whole US is much, much easier thanks to the work that that team has done. So what I'm going to do is I'm just going to do that same kind of st contains operation. You can see it here, pretty much the exact same syntax as we did a minute ago, but for this much, much larger. And just to show you the buildings polygon data set, here's the actual count. So we're doing a count here. And so it looks like this is, let's see, so 178 million building polygons. So that's 10 billion GPS points that we are joining to 178 million building polygons. And these are all spatially joined. So the point has to be within the polygon for it to count it. Which if you've done spatial joins, you know that's a very expensive operation computationally to determine if something is within something else geographically. So we'll do that same operation. We'll get our output here, same as before. And the actual operation to do that join took 2 minutes and 27 seconds. So 2 minutes and 27 seconds to join 10 billion GPS points to 100 and about 80 million building polygons. And then
Um,
for the last step, what we're going to do is, oh, sorry, go ahead, Ben.
sorry, I was going to say that Edric had a good question, which is how big is your cluster? Which runtime are you using?
This is the large.
Okay, cool. There you go. So if you want to know what a large is, it's all serverless, so it's like spins up and spins down. But we sort of aggregate those in terms of what we call spatial units, sort of similar to like DBUs if you're familiar with Databricks. You can see what those look like from a config perspective and a spatial unit perspective on our docs page.
Yeah. And I've also done this demo with medium cluster in the past. Usually the queries just take a little bit longer, maybe an extra minute or two. So it's usually not a big issue. I just didn't want the poor audience on the webinar to suffer while I run slightly longer queries, even though they're still pretty quick. So for this last step here, what we'll do is so now we have all of these polygons with all these points joined to them, and we're just going to aggregate it. And we're going to say, okay, well, for all of them, let's collect them in an aggregation so we can show how many visits actually came to a given building. And now this is a limited, it's limiting it to, I think, 10,000 points. Let's see if I can make that bigger. There we go. That's a little bit bigger. I'm just going to zoom in here. It's randomly selecting which building polygons it shows. So it is not a complete view. Obviously, there are a lot more buildings than the ones that are highlighted here. But hey, look at that. I think I actually got the San Francisco Ferry building in it. So I must be aggregating over a short period of time because I'm seeing 127 points, but it's also simulated data, so I probably wouldn't necessarily put too much stock into that. But yeah, we can see how much time and how many visitors we're seeing at these buildings over these spans of time. And so there we are. That's downtown San Francisco looking at a few different visits. I don't think that's a building. I'm not sure what that one is. I'll have to look into that. That's kind of interesting. That's on the bridge there. Um, but that's the idea. So as far as use cases that you might see, this one comes up a lot in ad tech use cases. And so we see cases where people are selling ads, media companies that are selling ads, and they want to push ads depending on where devices have been or where people have been, where they go. We've even had semi-real-time use cases where customers are pushing ads to devices as they approach or when they're in the region of certain kinds of products. And so these might be mobile ads. They might be other types of promotional activity for customers who have opted in to text alerts, things like that. We see some use cases there. There are also a lot of analytics and sort of urban planning use cases so that you can figure out what areas are the most busy, what areas need better infrastructure, things like that. Ben, any use cases that I'm forgetting here? I know we see a bunch of them for this sort of analysis.
Yeah, I mean, I think, there was some interest or comments around for this particular type of analysis. I wouldn't say, well, maybe it would be. There's like oh, actually, here's a good one. I remember this came up with a larger like real estate organization, but it was around like planning of construction of homes.
Mhm.
So like if it was a very large builder, type organization that's, trying to figure out where they want to buy land based on where people are moving and then construct, use that as a mechanism to figure out where to construct new, large scale communities and invest in those projects. So anyway, that was an interesting one. They were looking at like taking the movement data, combining that with like data coming off of fleets from shipping like trucking companies that were, moving companies basically, um, social media data sets and fusing those all together to figure out, where was going to be the next hot place that people were going to move to. So anyway, that was
That's a
interesting.
great one.
Yeah.
Yeah, I mean, yeah, because this doesn't necessarily have to be aggregated to building polygons. We just do that because it's honestly a pretty data set and a really useful one. But you could be aggregating to zones in a neighborhood. You could be aggregating vehicle GPS around different zones. If your company has some sort of delivery zone analysis, we've seen a lot of connecting points to things like zip codes or other regional codes. Um, for different types of like vehicle tracking use cases. And I do see a question here about shapefiles, it looks like. I mean, I personally try not to use shapefiles. I use usually GeoParquet or we'll store things in Apache Iceberg in kind of a lakehouse structure on S3. But we can read and write from shapefiles. It just usually we suffer some performance challenges because of the nature of the shapefile itself. We generally see better performance with things like GeoParquet. And within Wherobots, you can actually manage and adjust your projections. There's some stuff in the docs for that I can certainly point you towards if that's helpful. There's also a question a while back. I don't want to lose the thread about ground truthing. So the ground truthing, of course, like I said, is going to depend on the use case. If I were trying to, let's say I'm like a grocery store company and I'm trying to determine how many people are visiting different grocery store chains, there are a few different ground truth data you can do. There are ways you can correlate things like receipt data to what you're seeing in visits. Usually you need some sort of a machine learning model built on top of that in order to get like a reliable ground truth. There are also companies that will put door sensors or foot traffic sensors in stores to a limited number of places so that you can build a ground truth model and machine learning model that adjusts your foot traffic GPS data based on that. But that gets really, really in the weeds of building these kinds of robust foot traffic data products.
Typically, Sean, like, what do you advise on folks in terms of like serving this data once it's been processed back to the end user? Like you mentioned, for example, the the web sort of browser sort of rendering problem with the Kepler, for example. Um, but I mean, oftentimes we see applications that are built like very heavily with H3 as an index as well. So yeah, I'm just curious on thoughts on like what the best way to serve this back to folks is.
Yeah, I mean, it depends on what their front end stack looks like. Generally, though, usually you want some sort of a dynamic way of generating vector tiles or PM tiles, which we have in Wherobots. I don't know. I think we touched on it in one of the slides, but maybe breezed past it. But we actually have a way of generating those kinds of tiles so that what you're able to view on the screen is pre-generated by the user's zoom level, by what's in within the window which can be served to a front end application like, if you're using Leaf Map or Mapbox or there are a bunch of other ones out there. Usually you can serve this sort of tile layer to make that easier to render and more flexible than just purely trying to visualize millions or billions of points in a poor memory constrained web browser.
Cool. All right. Well, we happy to take any other questions. If not, we really appreciate y'all's time today, and we'll be sending this out as a recording after the fact, so you can stay on the lookout for that.
If you are pursuing any use cases in this area or trying to work with, very large data sets, whether or not they are mobility data sets, definitely please reach out. We're happy to help and kind of give you our input on what we've seen that works and doesn't work.
Before I forget our CTA slide. So if you want to use our full like production level pro edition, you can do that really easily. It's all available on the AWS Marketplace, so you can get started really quickly. Sign up for our next session as well. We've got always new ones coming up. I don't think it's going to be on telco. That was actually one we did last. And then just reach out if you wanted to have a tailored use case discussion. Yeah, appreciate that.
Oh yeah. Yeah, I guess I didn't update that slide, but there we are.
All good.
Simon, or sorry, Grant Simons, yeah, we can reach out to you. We'll grab your information and reach out so that we can chat a little bit more. Uh, Janet, this notebook, we don't currently have this one published, and I think the big limiting factor there is the really, really heavy and simulated mobility data set. We just don't have that published in a way that's easy to access as a demo notebook. But we're happy to connect with you and share some of this with you offline, even though we don't have it publicly shared yet.
Cool. And thanks, Ted. Appreciate we're excited about the Databricks integration too. We had lots of interest in that. We were at the Databricks conference earlier this year, so we're going to be pushing hard on that one for sure. Cool.
Thanks. Really appreciate all your time today.
Yeah. Thanks, everybody.
Ben, any last words?
No, just appreciate the time. Thanks, all.
Cool. Thanks, everyone. Bye.
See ya.